Hi one and all. So in this video we shall study about two types of counters called ring counter and Jhonson counter. This is experiment number 7. Once again this experiment will also falls under part A. I already have mentioned many times in the previous videos the experiments which falls under part A are hardware experiments, and in the previous videos just I'm explaining the design procedure or the concepts that you have should be aware before practically implementing the concepts using hardware devices like trainer kit, patch cards, etc., and so on, right? So once again the objective of this video is to learn about two interesting types of counter called ring and Jhonson counter, and we have to design this ring and Jhonson counter using an shift register whose IC number is IC7495, right? And now we shall look at a pin diagram of IC7495, or in other words 4-bit shift register. This is the pin diagram or pin configuration of the IC number 7495. Actually this IC is also called as 4-bit shift register. Okay, 4-bit shift register. Okay, you will understand about what is means by shift, everything so on in few minutes. So first and foremost we shall understand what is a register means. Basically registers are memory elements. Registers are memory elements. As the name itself says, memory element means the purpose of it is used to store information, right, or store the data, correct? And since this IC is called 4-bit shift register, this shift register can store 4-bit data at a time. Either that 4-bit data can be 0000, all 4 bits are maybe 00, or 0001, or 1000, etc., and so on. Means basically this IC will act like an memory element, and the capacity of this memory element is 4-bit. That's why this is called as an 4-bit register, correct? Okay, now you may ask me, sir, why do we need register here or memory element here to design the counter? One simple example we can quote here at this point is, for example, let us assume we are focused on up counter. Up counter is the one which will count like this. Let us assume the counter present state is 0. It has to go to the next state. That's what up counter means. It will, the next state of the up counter will be 1, and the next state for the present state 1 in case of up counter will be 2. Similarly, then it will go to state 3, state 4, etc., and so on. We call this type of counter as up counter. So interesting thing here it is, if the counter has to go to the next state, okay, it should be aware of the previous state, right? Means there should be a mechanism inside the counter to store the present state, right? Then only it can go to the next state. So exactly for the same purpose here, to design any type of counter, you can go ahead with a memory element, right? So depending on the requirement, you may choose 4-bit shift register to design the counters, clear? But here we are not dealing with up counter like this or down counter like 4 3 4 3 2 1 like this. Instead of that counters, we shall talk about two interesting counters called ring and Jhonson counter here, clear? So just I have given a brief introduction about 4-bit shift register, or in other words I have given details about IC7495. Okay, as I said in the previous classes also, or in the previous videos also, that more details about this you will learn in theory classes, clear? Okay, now we shall talk about the pin diagram or pin structure or IC structure of IC number 7495. Then we shall think about, or we shall discuss about ring counter, and then we shall move on to Jhonson counter, clear? Okay, have a look at this IC or pin diagram. Have a look at this. So it is a totally 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Means it is a 14 pin IC or a chip, right? Okay, and as usual we need to supply ground to pin number 7, and to pin number 14 we need to supply voltage supply, right? And then interesting, pin number 1 is used to supply a input called serial input, and pin number 2, 3, 4, 5 are used to supply parallel inputs, right? And pin number 6 is used to control the mode of the operation. I will tell you what is that mode of operation means, don't worry. So it is a mode controller, make it simple. And pin number 9 and 8 is used to supply an input called clock. Okay, don't worry about clock, I will tell you what is actually the clock, okay, in few minutes. Basically for the time being, understand clock are nothing but inputs, a special type of input like that. Clear? Okay, then pin number 13, 12, 11, 10, I mean represented as QA, QB, QC, QD are outputs, are output pin. Clear? Okay, so once again I will repeat, the IC 7495, it's a totally 14 pin chip, and pin number 7 represent ground, pin number 14 represent voltage, and pin number 1 is used for providing an input, specifically serial input, and pin number 2, 3, 4, 5 are used to supply parallel inputs, and pin number 6 is used to control the mode of the operation, and 9 and 8 is used to supply clock inputs, a special type of inputs. Pin number 13, 12, 11, 10 are used to view the outputs, or make it simple, they are output pins. Clear? Now one important point you need to be aware along with this is, see, this shift register or this IC can work in two modes. One is serial mode, at a high level serial mode, and the second mode is parallel mode. Parallel mode means at a high level you can use this IC in two modes of operation. One is serial mode and the one is parallel mode. If you are using, or if you want to use this IC for serial mode of operation, then you need to supply input through pin number 1, I mean through serial input only, and in those cases parallel inputs will be left open. I mean we will not use pin number 2, pin number 3, pin number 4 and 5, right? And interesting, in case for this pin, I mean for mode control pin, you need to supply 0 as an input. Okay, because this, when you supply 0 as an input to mode control pin, then this IC will work in serial mode of operation. Clear? And you will get output at 13, 12, 11, 10 only. And one more thing is, when you are using this IC in serial mode, then clock has to be applied. Usually clock will be usually clock will be represented with a symbol like this, with a cap symbol like this. Okay, this represents positive edge of the clock, negative edge of the clock. I will come back to this later. Okay, you need to supply clock input to pin number or through pin number 9 when you are using this IC in serial mode, right? Clear? Okay, then you can, as I said, you can also use this IC in parallel mode also. So in those cases, this serial input will be left open. I mean you will not use pin number 1 in that case, and parallel inputs has to be supplied through pin number 2, 3, 4 and 5, and in this case for the mode control you need to supply 1 as an input. Okay, this 1 indicates that, or this 1 signal makes this IC to work in parallel mode. Clear? And as usual, at pin number 13, 12, 11, 10 you can view the outputs, and in this case you should not apply the clock at clock 1. Instead you should apply clock input through pin number 8. Clear? So with this understanding, we shall rename this clock 1 as serial clock, so that you people can easily understand when you are using this IC in serial mode, then you can apply clock through this pin number, and we shall rename this clock to as parallel clock. Parallel clock means when you are using this IC in parallel mode, then you should apply clock at pin number 8. Clear? So with this understanding, we shall move forward to understand ring counter. Okay, now we shall talk about ring counter. Okay, this is a special type of counter as I have already mentioned. Okay, and what are these? QA, QB, QC, QD are nothing but outputs of shift register, right? Outputs of shift register. So what are these? What this column represent? An input, a special type of input called clock pulses or clock. Make it simple. Okay, let us assume. Okay, first understand the operation of ring counter, then we shall talk about the circuit diagram, right? And in the coming video we shall see how we can able to implement this practically with the help of trainer kit and connect ICs and connecting wires. Clear? Okay, let us assume that initially the shift register was holding the data 1 0 0 0. I mean QA is 1, QB is 0, QC is 0, QD is 0. This is been represented over here. Clear? Okay. Initially the shift register has this value 1 0 0 0, and this 0 indicates that initial condition. Okay, if this is the state of the shift register or counter, clear? When you apply the clock, I mean when you press the clock, don't worry, I will tell you in the coming video where to supply the clock input and how to apply practically. For the timing, understand. Now if you apply the clock once, then how ring counter will work is the bit present in the QD position, the bit present in the QD position will be copied to QA position, So this is the first thing what it will do. The bit present in QD position will be copied to QA position, and the bit present in the QA will be shifted towards right, I mean to QB, and QB content will be shifted to QC, and QC content will be shifted to QD. So hence as a result 1 0 0 will become 0 1 0 0, right? And again if you apply the clock for the second time, these two indicates applying the clock twice. Again what happens? The bit present in the QD position will be copied to QA position, and the bit present in QA will be copied to QB or will be shifted to QB. QB content will be shifted to QC. QC content will be shifted to QD. Again if you apply the clock for the third time, then the content of QD will be copied to QA, and QA content will be shifted to QB. QB content will be shifted to QC. QC content will be shifted to QD. Clear? So see, if you observe carefully the bits, I mean if you focus only on one was here initially, for the next time it came here, next time it is coming here, for the next time it is coming here. Means can you have a feel like the bit is shifting towards right? Bit is shifting towards right. Hence this is also called as an 4-bit, or make it simple, shift register. Hence it is also called as an shift register. Clear? And again you can repeat this experiment for finite number of times, and you can observe how it is behaving. This if the counter behaves like this, then that type of counter is called as an ring counter. Clear? So did you understand about ring counter? So basically it is a shift counter. Clear? Okay, now we shall a little bit touch upon connection part. Okay, see, as you can see here, inputs, for the connection part, this pin number 2 3 4 5 will be left open. Will not provide any inputs to this pin. And see here, mode control, for mode control pin you are supplying ground, means actually 0 means you are using that shift register in serial mode, and hence you need to apply the clock to the serial clock, to pin number 9. And see here, QD content is being shifted to, or it has been given as an input for the next phase. Can you see here? Clear? Okay, then this QA, QB, QC, QD should be connected to output pins, right? And clock 2 will be left open. We don't use this parallel clock or clock 2, and pin number 14 should be connected to VCC, right? And pin number 7 should be connected to ground. That's it. This is the connecting part, and practical implementation we shall see in the coming videos. Clear with this, right? So next we shall move on to another interesting type of counter called Jhonson counter, which is actually a modified version of ring counter. So what is that modification? Simple. So again, treat this as the initial condition of the counter. Okay, I mean initially the shift register is holding 0000 as a value or as its content, right? Okay, now what Jhonson counter will do, see, it will take QD value or the bit present in QD, then it will do complement first. I mean it will complement this 0 complement is 1, and that 1 will be placed in a QA position. Clear? And as usual, QA content will be shifted to QB content will be shifted to QC content will be shifted to QD. So when this will be happen, as I mentioned in case of ring counter, when you apply the clock. Okay, this 0 indicates initial condition. When you apply the clock, I mean more specifically, if the counter has this value 0000, and if you apply the clock, now the present state will be 1000. Clear? Okay. And again, once again I will repeat, if this is the present state, and when you apply the clock for the second time, again it will take value or the bit present in the QD position, complement it, okay, or negate it. 0 negation is 1, and that 1 will be placed in QA position. Then QA content will be copied to or shifted to QB content will be shifted to QC content will be shifted to QD. Once again, for better clarity, we shall go to the next iteration. Okay, again if you apply the clock, as usual it will take a bit present in QD, complement it, I mean 0 negation is 1, and that 1 will be placed in a QA position. QA content will be shifted to QB content will be shifted to QC content will be shifted to QD. Like this counter will work. Clear? Did you understand how Jhonson counter will work? Okay, now we shall touch upon the connection part, right? Connection part. See here, what is that modification? See, in case of ring counter, directly we were connecting directly QD to serial input, right? But whereas in case of Jhonson counter, which is actually a modified part, instead of directly connecting that to serial input, first we will complement it. Can you see NOT gate here? Whose IC number is? What is the IC number of NOT gate? 7404. So input pin number will be 1, output pin number will be 2. So don't connect QD directly to serial input. Instead, pass that to the NOT gate first. I mean complement it first, then provide complemented 1 as an input. Clear? Again, even in this case, we will not use this shift register in parallel mode. Hence, these pin number 2, 3, 4 and 5 will be left open, and mode control, since we are working in serial mode, we need to supply 0. Pin number 7 should be connected to ground, and this clock 2 will be left open because we are using that shift register in serial mode, and we need to apply clock to pin number 9, which is a serial clock, and pin number 13, 12, 11, 10 should be connected to outputs because this is the place where you can view the output, and pin number 14 should be connected to voltage supply. So this is about the connection part. Clear? Okay, so finally I will conclude this video. So just what we did is we learned about two interesting types of counters called ring counter and Jhonson counter, right? And the aim of this experiment is to design these counters using an IC 7495. Along with this, we will also use NOT gate. That's why 7404. Clear? What is this 7495? Basically, it is an shift register. And what is the purpose of shift register? Shift register will act like an memory element. Specifically, this will act like an 4-bit memory element. Clear? So in coming videos, we shall see practically how we can able to implement or how we can able to verify these counters practically with the help of trainer kit and patch cards. Thank you one and all.